Hello and welcome to the third lecture on high performance computing. In this lecture, I will give a brief about PRAM model and the characteristics of parallel random access machine model, as well as I will give you the brief about different types of PRAM model and how these models differ from one another. And moving on, on the second topic, I will give you a brief explanation that how an algorithm designed for one PRAM model can also run on other PRAM model, and what are the time complexity of PRAM model that runs on one platform to another platform, and whether the complexity of the algorithm is different from the time complexity of the algorithm which is designed for another model of PRAM. And in the third topic, I will give you some of the brief of PRAM algorithms. And in the next lecture, I will give some examples of PRAM algorithm. So before going to the PRAM algorithm or parallel algorithm, I will give you a brief about the some of the constructs that are used in writing PRAM algorithm. So moving on, I welcome you all to the third lecture, and we start with the PRAM model. So already we have discussed the PRAM model. I have given you the brief of PRAM model in the first lecture and in second lecture also. But in this lecture, I will give you some of the characteristics and features of the PRAM model, as well as the different types of PRAM model and how they differ from one another. So now let's start with PRAM model. So parallel random access machine is a straightforward and natural generalization of random access machine. So it is actually an extension of random access machine, and it is an idealized model of shared memory, SIMD, single instruction multiple data machine. Its main features are as follows. So it consists of unbounded collection of numbered RAM processors. So in random access machine, we have discussed a RAM machine has a single processor, and each processor has its own memory. Memory of the processors are denoted by registers R0 to Rn number of registers. So similarly, in PRAM model, it consists of unbounded collection of RAM processor. So it depends on how many number of processor is required to solve a particular complex problem. So when we come to the algorithm, some examples of PRAM algorithm, then we come to know to solve any particular problem, how many number of processors are required and how they differ from one problem to another problem. And the second feature is it consists of unbounded collection of shared memory cells. So as we have already discussed, in parallel random access machine, it uses a shared global memory, and shared global memory is shared by all the processor which are concurrently using the same shared global memory. So it also consists of multiple memory locations denoted by M0 to Mn. Each processor has its own unbounded number of local memory, that is registers, and each processor is denoted by its index, that is Pi, And we have already discussed it consists of unbounded collection of RAM processor P0 to PP. Moving on, each processor can access any shared memory cells. So simultaneously and concurrently, multiple processors are reading the data from same shared global memory and writing the results into same shared global memory unless there is read or write conflicts. And how the PRAM model handle the read or write conflict that we will see in the coming up session. So next, moving on, input of PRAM algorithm consists of n items, and usually these n number of items are stored in the first n set of location of unbounded collection of shared memory cells from M0 to Mn, and output of any PRAM algorithm that is produced by the PRAM algorithm consists of n dash number of items, and these items are stored consecutively to the next location of input data, and it is denoted by n dash. So n dash is for output and n for input. All the PRAM algorithm instructions execute in three-phase cycles. So first, any PRAM algorithm read the data from shared memory cell. So if n number of processors are activated, all processors simultaneously read the input data from shared memory cell. Then each processor perform its local computation, and in the third phase, all processor write the results into same shared global memory cell. So all these processors execute three-phase instruction of PRAM in synchronous manner. And PRAM has the ability, each processor of PRAM has the ability to make a special assumption that how they perform or how they handle read conflict and write conflicts in the shared memory cell. So in PRAM model, uh, the only way to handle the read or write conflict by a processor can exchange data is by writing into and reading from same memory cell. So at a time, if we allow only one processor to read or write the data, then there will not be any read or write conflict. But if multiple processor attempts to read the data from same shared global memory, and how they write multiple processor, how they write the data to the same shared global memory. So uh, in that scenario, how it handle the read or write conflicts. So that we will see. And next, moving on, as we have already discussed, P0 is the first processor, and P0 has a special activation register specifying the maximum number of processors required to perform any computation. And first, the P0 processor is activated, and then it computes the number of required active processor to perform the computation. Then it loads uh, this register, and then other corresponding processors start executing their programs. Computation in PRAM proceeds until P0 halts, at which time all other active processors are also halted. And in order to perform performance measure, So in a parallel algorithm, we also compute the parallel time complexity and space complexity. So a parallel time complexity in PRAM model is computed by how much time has elapsed for P0 computation. So P0 initially start and then it load the required number of processor which is required to perform the computation, and all processor P0 and all other processor perform the computation, and then all processor halts, and finally the P0 processor halts. So what is the time taken by P0 processor to perform the computation? The total time is known as parallel time complexity of that algorithm. So that we will see. Next, space complexity. Space complexity is computed by the number of shared memory cells that are accessed by multiple processors simultaneously. Moving on, so these are some of the basic features, and now it has some characteristic feature. So there are 5 characteristic feature of PRAM model. So the first one is it is natural. So the number of operations executed per one cycle on P processor is at most P. It is strong. Any processor can read or write any shared memory cell in unit time. So that's why it is strong. It is simple. It abstracts from communication or synchronization overhead. So it handle all kind of synchronizing with other processor, as well as the overhead involved in reading or writing the data. So that's why it is powerful and simple. The PRAM model is powerful and simple, and it correctly analyzes the PRAM algorithm very easily. Uh, Fourth point is it can be used as benchmark. So if a problem has no feasible solution or efficient solution, it has no feasible or efficient solution on any parallel machine. So if it has no feasible solution on PRAM, then we cannot say that it has feasible solution on other parallel machine. It is useful. It is an idealization of existing shared memory parallel machine. So now we come to the architecture of PRAM model. So this architecture we have discussed in the first lecture also. So this is the basic architecture of PRAM model. It has a control unit. It has unbounded collection of number of processor P0 to PP, and it has unbounded collection of memory cells known as shared global memory, and the processor and the number of processor and shared global memory cells are connected by some form of interconnection network, and control unit controls the operation of processor and the shared global memory. So this is the basic model of PRAM, and as I have said you, a PRAM consists of a control unit, a global shared memory, and an unbounded set of processor. Each processor has its own private memory, and this model was proposed by Fortune and Wiley in 1978. So this was the basic proposed model of PRAM, and As we have discussed, a PRAM computation begins with the input stored in shared global memory, and initially a single active processor is there, which is which compute the required number of active processor, and then it load the other processor. Then all other processor perform their computation of reading the data, performing the computation, and writing the results into same shared global memory simultaneously. So all the active enabled processor may read a value from single private or global shared memory location. Each processor perform a single RAM operation in case of each processor, and each processor write the results into temporarily into their local memory, and finally into the shared global memory. So until and unless all processor executing the same instruction, there will not be any problem. But if multiple processor executing different operations simultaneously, then there will be read or write conflicts. So, and now I would like to give you an important concept of PRAM algorithm. That is, cost of any PRAM algorithm is computed by uh, finding the product of uh, number of processor used, and what is the time complexity of PRAM algorithm. So if we say there are p number of processor, and each processor takes log p time to execute all the instruction, then cost of PRAM processor or cost of PRAM algorithm cost will be p theta p multiplied with log p. So that we will see why it is log p and why not other. Then when we come to the examples of PRAM algorithm, then we able to see what is the concept of taking logarithmic time by the p number of processor. So there are various PRAM model differ in how they handle read or write conflict. That is, when two or more processor attempt to read from or write to the same shared global memory. So based on how they handle the multiple read-write conflict, there are three variation or three types of PRAM model that I have told you in the first class. So there are EREW model, that is exclusive read, exclusive write, and in this model, this is the basic model of PRAM. So at a time, only one processor may read the data from same shared global memory, and at a time, only one processor is allowed to write the result into same shared global memory. So there will not be any read or write conflicts in EREW model. And second type of model is CREW, that is concurrent read and exclusive write. In concurrent, it allows multiple processor to simultaneously read the data from same shared global memory, and but they all read the data during same instruction step. But this model does not allow multiple processor to write the result at a time. So at a time, only one processor is allowed to write the result. So there will be, uh, this is the default model of PRAM, and the CREW is one of the default model of PRAM model. Third type of PRAM is CRCW. CRCW is concurrent read and concurrent write. So in this model, concurrent reading is allowed and concurrent writing is also allowed. And there are variety of CRCW model exists with different policies for handling concurrent writes to the same global address. So there will be three different models of CRCW, that is common, arbitrary, and priority model. Common, arbitrary, and priority model. So in common model, all processor concurrently writing into the same global address must be writing the same value. So if different processor is writing the different value, then there will be a problem and it will not able to handle. So if multiple processor are writing the same result, then in common model it is allowed that all the processor can write the result into same shared global memory. Second type of model is arbitrary model. So in arbitrary model, if multiple processor concurrently write to the same global address, one of the competing processor is arbitrarily chosen as the winner and its value is written into the register. Then its value will be written into the same shared global memory, and then the remaining processor, among the remaining processor, the arbitrarily chosen winner will be allowed to write the result, and going on and so on and so forth, and all the processor writes their result into same shared global memory. And third type of model is priority model. And if in priority model, if multiple processor concurrently write to the same global address, the processor with the lowest index succeeds in writing its value into the global memory location. And going on further, the other index will be allowed one by one. So highest priority will be the processor with lowest index value. Then we move from simulation from one model, PRAM model, to other PRAM model. We know that there are three different type of PRAM model: EREW, CREW, and CRCW. Among these three different model, EREW model is the weakest model, and a CREW can execute a algorithm or program written for EREW in the same amount of time. If we write an algorithm for EREW model, but we want to execute the algorithm on CREW, and if we do not use its concurrent reading facility, then the same algorithm on CREW will take the same amount of time. But if uh, we allow concurrent reading facility, then this algorithm on CREW will take less amount of time than EREW model. Similarly, a CRCW can also execute the same EREW model, a EREW algorithm in the same amount of time if we do not allow concurrent read or concurrent write. But if we allow the facilities of concurrent read and concurrent write, then the same algorithm will be executed in less amount of time than the amount of time taken in EREW algorithm. So here you can understand uh, any algorithm which can be developed for one model of PRAM can be executed on other model of PRAM if we does not use the facility or characteristic of other model, and we allow to execute with the same facility that is given in EREW, then it will take the same amount of time. But if we change the policy, that is, if we allow concurrent read and concurrent write facility, then it will take lesser amount of time than the previous time of the algorithm. CRCW model has three different type of PRAM as we have discussed. That is common model, arbitrary model, and priority model. And among these three model, priority model is the strongest, and any algorithm designed for the common PRAM model will execute with the same complexity on the arbitrary PRAM and priority PRAM as well. If all processor writing to the same global, same location, write the same value, then there will not be any problem. And choosing an arbitrary processor would cause the same result. Likewise, if an algorithm executes correctly when an arbitrary processor is chosen as the winner, the processor with the lowest index is as reasonable as alternative. Hence, any algorithm designed for arbitrary PRAM model will execute with the same time complexity on the priority PRAM model. Since because the priority PRAM model is the strongest than the EREW PRAM model, an algorithm to solve a problem on EREW PRAM can have higher time complexity than an algorithm solving the same problem on priority PRAM model. So uh, we have uh, we have a concept used here, that is priority PRAM uh, is the powerful or strongest model than arbitrary PRAM model, and arbitrary PRAM model is powerful model than common PRAM model, and common PRAM model is powerful model than CREW and EREW model. So this is how we understand the strongest PRAM model and how they differ from one another. So here we stop, and we discuss in the next lecture, we discuss about some of the basic concepts of PRAM algorithm, and then we start with some examples of PRAM algorithm. And in this lecture, we have discussed the uh, the features of PRAM model, and some of the characteristic feature and different types of PRAM model, and uh, we compared the performance of each PRAM model, which PRAM model is better and how they are better, and what are different type of PRAM model, and what are different type of CRCW model, which is powerful and which is less powerful, how we can execute any algorithm designed for one PRAM model on other PRAM model, and if we use the facility of other PRAM model, then the time complexity will be lesser. Otherwise, the time complexity will be same. So this is how all model differ from one another. And in next lecture, we will discuss about PRAM algorithm and examples of PRAM algorithm. So thank you very much for this lecture. And here we stop. So in the next lecture, we discuss about the remaining things. So thank you very much.